Welcome to qnawire.
We're going to analyze the NMR spectrum for ethylbenzene. In this case, ethylbenzene corresponds to the following molecule. We're going to have our benzene ring and an ethyl group. Over here, CH2, CH3. Recall that each of these carbon atoms is going to have one hydrogen, and we're going to see which signal we're going to have. So first of all, in the aromatic region, over here, we're going to have a singlet signal that is going to account for a total of 5 hydrogens. In this case, we're going to look at this and see that it appears to be a singlet because since the structure that we're going to get, the difference in between the hydrogens on this position and the hydrogens over here, the ones in purple, and the hydrogen over here in red, is going to be close to nothing. So each one of these guys is going to be a single on its own. So actually what we're seeing, even though it seems to be a single peak, it is actually a multiplet coming from the mix of 5 hydrogens. But what we know is that all of the hydrogens that we see on the aromatic region are going to come from that part. Hi, so over here we're going to have the NMR spectrum corresponding to ethylbenzene, and what we're going to look over here is the different patterns that we're going to have. So first of all, this methyl group is going to be, since we're going to have two neighbors, this is going to correspond to a triplet that integrates to 3 hydrogens. In this case, that triplet corresponds to the one on this region over here. Next up, the CH2 that is next to an aromatic ring. This guy is going to have 3 neighbors. So this is going to correspond to a quartet integrated into 2 hydrogens, which is going to be the one on this region. And finally, the 5 hydrogens from the aromatic ring, they are all going to appear mixed up together as a single cycle. So all of these guys are going to be the aromatic hydrogens, and all of that signal is going to integrate up to 5 hydrogen atoms. In this case, we're going to see not a big difference in between the aromatic hydrogens that are next to the ethyl group, the ones here and here, because the coupling constant is not going to be the coupling constants are not going to change that much, and the shift due to the presence of the CH2 group is not going to be very significant. So formally, the ones that are actually equivalent are the guys over here. Next of the other ones that are equivalent would be the ones over here, and the one that would be lonely would be this one. So you would expect to have 3 different signals from the aromatic compound, but since the difference in shift is not significant at all, at the end it gets all mixed up as a single signal. So with that, it would be all. Thank you very much and have a good one.